All right, hey, hello everybody. My name is Joe Rayo, and I'm going to go ahead and let's go ahead and get started. If everybody could take a seat. So I have been a professional services consultant with Teradata since the beginning of our Hadoop offerings, and through a lot of my experience and with a lot of different customers in the Hadoop space, I've found a lot of different design patterns, and I want to talk about those today. So I'm going to talk about Hadoop is not an island in the enterprise. Strengths and deployment practices that merge Hadoop and a data warehouse together. So this presentation is going to be split into two different parts. The first is going to talk about the relative strengths of Hadoop and a data warehouse based off of the technology that goes behind it. And once we have a good understanding of those relative trade-offs, we're going to go into the second piece here, which is some customer examples and architectures that we can draw from that actually accomplish some goal using both of them together. But first, I want to frame the discussion a little bit. So here at Teradata, we're going to talk about the two appliances that we use, although they can be extended to other platforms as well. The data platform, Hadoop, and the enterprise data warehouse, I'm going to focus mainly on the Teradata database. So again, it can be extended to any database that's in production. And both platforms really could, if you wanted them to, handle the entire data center workload by themselves, if you really wanted them to. You get a strong Teradata guy, a really Teradata biased guy, he'll say that everything can be put in a data warehouse. You get a Hadoop biased guy, which I'm sure a lot of people in this conference are. They'll say you can do a lot of things, almost everything on Hadoop. And the thing is, they're both right. Both platforms really can do everything if you really, really want them to. But the question is it actually worth it to put something on this platform for somebody that doesn't have that skill set? So kind of when we're talking about this, I want to think about an enterprise that doesn't have any sort of data center infrastructure, any expertise, any expenditures at all. What would they do when it comes to building an architecture for their data if they're trying to build this thing from scratch? That way we get rid of the biases, we get rid of the existing technologies, and we're talking about a clean slate, what makes sense to start off with. And then we can analyze more straightforward, without bias, the strengths of both of the platforms. So let's talk about the data warehouse. This is what Teradata has been doing for years. We've been putting up SQL engines to handle the business transactions in the center of an enterprise for about 30 plus years. And this has been a central repository for relational data in the business. We handle thousands of concurrent users and queries. We have full ANSI SQL, very complex query logic. We can do advanced workload management. We have we can have full transactional capabilities. We have very secure access down to the row level. It's a very robust platform for putting all of a business's relational data in one central location. Now, if we stick Teradata in an enterprise all by itself, and we have been doing this for a while, then we're kind of thinking in the old way. We've got all of this new technology around big data and Hadoop, and if we just stick a data warehouse in a data center all by itself, then somebody might be thinking, well, why would I need to change? I've been doing this for 20, 30 years. It's been working. Why would I need to change? And a company that's been doing this would be missing out on the new opportunities that Hadoop is bringing. Hadoop is really changing the game. So when we talk about Hadoop, of course, which most people here are familiar with, it's Hadoop Summit after all. Its major strengths include it's extremely economical to store large amounts of data on Hadoop. It is able to process abnormally large data sets, web-scale, giant-scale data sets. It's extremely flexible in the amount of storage and processing it can do. It doesn't need to fit a relational model, a SQL model. And it's open source. It has an active community development. It's not limited by that proprietary model in certain senses. So we've got this new platform. And one of the tough things with Hadoop is it's brought challenges is that it's very difficult to stand up in an enterprise, difficult to stand up a new Hadoop cluster, install it, provision the hardware. So we kind of mitigate that with an appliance of our own that pre-installs, pre-tunes, gets all of these things, got monitoring, management, all on one box. Now it's got full support. It's pretty much you land a Hadoop cluster in the middle of your data center, and it is ready to roll for production work. So we take care of that headache, that traditional headache with standing up a Hadoop cluster. However, what are the problems with sticking Hadoop on a data center all by itself? Well, you can see first of all, Hadoop gets a little lonely. But the issue is, certain people, especially the companies that are kind of techie startup companies in Silicon Valley, would think, well, it's free, it's the new thing, it's open source, it's the new wave. Why would I go back and consider using an enterprise data warehouse? And one issue with this is that Hadoop kind of goes beyond its maturity and design. It can go a little bit beyond its maturity, and some people may be using Hadoop for areas that it is not really designed for. It was never really built for that high concurrency business transaction type data store. And this is a presentation. This is a slide by Winter Corp, a data warehousing kind of a research group. And they did a study on what's the total cost of ownership of both of these platforms. And you can see on the left, we have a platform that's very data warehouse specific, concurrent queries, business transactions, complex SQL logic. And you can see the total cost of ownership. Excuse me, I got that backwards. On the right is the enterprise data warehouse graph. And you can see on the right side, the total cost of ownership of a data warehouse is actually lower than Hadoop for these type of workloads. But for traditional big data type workloads, data that is very large, that is non-relational, those kind of workloads, you can see that graph on the left, the total cost of ownership of a data warehouse is actually greater, and a lot of that is due to the initial acquisition cost from the licensing of the proprietary software. So the point of this is that both of these kind of have their own niches for workloads that make sense on them. And if we can take advantage of both of these niches when it comes to designing workloads for our two platforms, we can save money and we can use both of these platforms for what they're designed for. So successful enterprises merge the strengths of both Hadoop and the data warehouse to accomplish their goals. So with that, I'd like to talk about some combined architectures between the two. How do we combine these two in the real world to accomplish some of our goals? And I'd like to lead off all of these with a little bit of a use case that I've run into during some of my work as a consultant with Teradata. So the first case is with a large insurance company. They had lots of different vehicles in an enterprise fleet they wanted to insure. So with this insurance company, we have lots of business type data. We have the index of all of the vehicles. We have the payments, the payment information. Then we also have telematics data here. We have data for GPS coordinates for all of these different vehicles at certain points in time. We have information about when the vehicle is accelerating. Every time these little dongles are plugged into the vehicles are turned on, they just start recording machine data about the cars over and over and over again, once a second, many times a second. We get GPS location, speed, accelerometer data, And this company wanted to find a way to do analytics on this data to make to make sense of it. So the architecture that we used in this case is just straight up splitting the workloads. This is kind of the first architecture for the combined. So the business transactional data, we just stick that on Teradata. We run those workloads on Teradata, and things like the big data type workloads, the machine data, the GPS data, the accelerometer data, the data that's too cost prohibitive and too large and value sparse to stick in the data warehouse, we analyze that with our Hadoop platform. So the kind of the rationale for this architecture is that it really isn't economical when, and I like to use value density as a term here. If the data is very value dense, if there's a lot of value per record, then it makes sense to put that data in the data warehouse. Whereas if there's not very much value per record, if you need to aggregate thousands of records in order to gain some sort of insight, then it makes much more sense to put that on a big data platform like Hadoop. Now, same with the business transaction data. Hadoop really wasn't built for those kind of business transactions, and while there are a lot of effort to put that out there, it's not exactly there yet for a lot of big enterprises. So it is a very straightforward way to just split the workloads up. The big data type workloads, stick them on our Hadoop platform. The business transaction type workloads, stick them on our data warehouse. And the business value we get out of that is we can take advantage of the cost and performance benefits of both platforms. And because we're using Hadoop now, we didn't have this ability before in the enterprise. We can gain new insights with our new data sources that we could not gather before. The second of the 4 architectures I'd like to discuss is with a large computer manufacturer that we did work for. They had a lot of Omniture data, weblog, clickstream data that they wanted to analyze and make sense of. And this was very prohibitive to store and analyze, and also because the Omniture data is kind of, when you think about it, it's kind of messy. If any of you ever worked with Omniture weblogs are kind of messy to work with. There's not a lot of data quality kind of built into the Omniture weblogs. So ETL work was a very huge amount of the processing and headaches on this data set for this computer manufacturer. So what we used here is a ETL type architecture. We offloaded and we used Hadoop as an ETL platform. We brought the source data directly into Hadoop. We used Hadoop's robust capabilities to process and do data quality and merge data together. And then we brought the cleansed business transaction ready data into the data warehouse. So we can see that there are a few reasons this works. Hadoop being a write once, read many architecture, we can stick this data that only needs to have processing done once or twice on it, and we can run it at scale. And then this data can be transferred as it's done into the data warehouse. In addition, we can retain the raw source data for data lineage purposes on Hadoop using this type of architecture. If there's a problem with the data downstream, we can go back to Hadoop and see what exactly is the problem on the original raw source data. And Hadoop can economically store this source data for long term. Finally, there are many cases where this doesn't make sense. I don't want people to leave here and think, hey, I should take all of my ETL workloads off of my data warehouse and stick them on Hadoop. That doesn't necessarily make sense in all cases, but because Hadoop is relatively inexpensive compared to a data warehouse, we can use this to take storage and processing power off of our relatively expensive data warehouse and put them on a platform that is much more economical for those workloads. Now, how do we actually get the data between Hadoop and the data warehouse? Well, we have a connector. It's a scoop connector that actually moves the data in bulk between the two platforms. It runs on the Hadoop side, and it just connects as a MapReduce job. And this is kind of what it looks like. You can see that it runs just as a MapReduce job, and there are a lot of different options for bulk moving data between a Teradata system and a Hadoop system. And we could stick this, say, at the end of a normal ETL job in Hadoop. We could just do an ingest with, say, Flume. We could do some Hive queries, Hive processing, pig processing, and at the end of our ETL script, we could run something like this to just mass move the data into our data warehouse, and it's ready for operational business transaction type queries. Now, the business value of our ETL type architecture is that because of the relatively expensive limited storage and processing capabilities of our data warehouse, because that's more expensive, we can take these one-time jobs, stick them on our Hadoop platform, and then we can save money and space and processing power on our data warehouse by doing this. And we also have, because of Hadoop's ability to store extremely large data sets at scale, very inexpensively, we have the ability to keep our raw data in an inexpensive way. That'll save our business money by having to, and it'll give us opportunity for data lineage. Third architecture I would like to discuss is with a bank, a very large national bank. They wanted to put lots of financial data on their Hadoop platform. However, they ran into a few problems with accessing the data and with security. Both of those kind of gave them some headaches. With accessing the data, they had a lot of users that weren't familiar with Hadoop. Most of their entire enterprise was SQL friendly. They were completely dependent on data warehouses, and they had no familiarity with SQL. Now, Hive was an option, but they also weren't really familiar with Unix-type programming. The second thing with security is that because it's financial data, they required a lot of very strict security controls. And Hadoop's current simple authentication didn't work for them, and Kerberos would have broken connectivity between certain applications that they wanted to use. So they had a little bit of a headache with accessing their Hadoop data. So what we did was that's actually backwards. We put Teradata in as an access layer for Hadoop, and excuse me, this is a backward slide here. Imagine the queries going into Teradata first, subqueries going to Hadoop, data going from Hadoop to Teradata, and then back out to the user. So in this case, the data warehouse users can access the Hadoop data without any knowledge about how Hadoop works. You can just encapsulate it in a view, and you can get to your Hadoop data without having any sort of knowledge of Hadoop's inner workings. You can use the full SQL library of your data warehouse, your SQL type engine, to access this data. And you can also use it to secure your Hadoop data if you, say, put Hadoop behind a firewall and use your data warehouse as an access layer. And the way we do this is with a technology we call Query Grid that allows us to mass move data from Hadoop to Teradata all at once. So a query grid is a SQL function that is a parallel-to-parallel data transfer. The data nodes talk directly to the individual worker units called AMPs on our Teradata platform. So it's scalable, and because it's a SQL function, our users in Teradata can access our Hadoop data without any knowledge about how Hadoop works. And because it's also in Teradata, we can put it behind views. So this is kind of what a call looks like. We call it the function load from hCatalog. We can put these behind views and then put individual security rights and roles behind these views so that only authorized users can access the data they want, and they have to do it through our data warehouse platform. Now, there are a lot more options here than are listed. This is just a brief example. But through using Teradata Query Grid, we can use this is what I call a secure access architecture for Hadoop. And the business value of using this is, of course, we can leverage our existing SQL user base in Hadoop. Our existing ETL community can leverage our Hadoop platform. And we can inexpensively, securely, and accessibly access our Hadoop data all at once. The final of the 4 architectures I'd like to discuss is a large pharmacy that we worked with. The large pharmacy had a problem with storing a lot of their archival data. They had thousands of pictures, images, and they had a problem storing all of this in their main data warehouse. And using tape was a problem for them because they couldn't. It's very difficult to access data that's on tape, even though tape is a long-term storage alternative. So how we used Hadoop here was an active archive type architecture. We can put our cold data, our historical data, and regular backups from our Teradata platform onto Hadoop. Now this has a few advantages over something like tape. We can access this data on the fly at any time. It's an active archive. You can log directly into Hadoop, or we can use our Teradata Query Grid connector or our Teradata connector for Hadoop. We can access this data anytime we want while the platform is still up and running. And we also have freed valuable space on our data warehouse by not having to store this cold data that we're not accessing very much. So the Hadoop gives us some key advantages over a long-term backup solution such as tape or net backup or something like that versus keeping it on an active data warehouse platform. We have the cost benefits of that. So here are some of the business value of this architecture. We free up the cold storage space on our data warehouse, and we can still analyze the data on our Hadoop platform. So just to make some concluding remarks here, these 4 architectures are not mutually exclusive, of course. Data enterprise areas that have matured in their coexistence systems that are using both Teradata and Hadoop, or any data warehouse and Hadoop together, you'll see variants of all 4 of these architectures kind of being used concurrently. You'll see workloads being split based on where the workload makes sense on the 2 platforms. You'll see Hadoop being used to offload some of the ETL from the platform and also use it as an active archive. And you'll see the data warehouse being used as an access layer for those who are not familiar with Hadoop. And another thing I would like to mention is that we're just going in and replacing existing data centers with their new counterparts, like going into a place that has Teradata only and trying to replace a lot of things with Hadoop. Same with Hadoop, trying to go into a place that's actively using Hadoop and replacing it with our data warehouse is not really a feasible goal, just because this is, again, done with a system, a data center that we were discussing that didn't have anything provisioned yet. A lot of times it makes more sense to keep things on the existing architecture mostly and migrate slowly. So in this case, using these dual concurrent architectures, we can get our foot in the door in a lot of these enterprises that are very entrenched with the data warehouse and give them key business value with adding Hadoop to their data center. So with that, I finished a little bit early, but are there any questions from the audience? Yeah.
Query grid, can you explain a little more? Is there any type of optimization? I mean, where is that work being done? Or is it kind of you send your data off? Is it pulling data from both the Teradata warehouse and Hadoop, or is it one or the other?
So the question was, can we go into a little bit more detail about how Query Grid works under the covers? So Query Grid actually is, it reads directly from there are two methods for Query Grid. It can read directly from HDFS and pull the data in bulk towards Teradata over the pipe, and then do transformations on Teradata that the outer query requires of it. Then there is a version of Query Grid that actually sends a subquery into Hive. It'll actually do some processing and stage it in a temporary table on Hive, then migrate the data in bulk to Teradata in parallel, data nodes talking directly to amps. Then it will drop the temporary table in Hive so that data doesn't stay persistent and take up space. So there are kind of two ways that works. And the simplest Query Grid method is just a bulk data movement across the pipe, no processing done on either side. You could send a Hive subquery. You could have a greater outer query on Teradata that does processing as you want on either of the two systems. Yeah? The Teradata connector for Hadoop is just a MapReduce job. So it can run on many different Hadoop architectures aside from just the Teradata appliance for Hadoop. The question was, does the Teradata connector run on only the Teradata appliance? No, and the answer is no. It runs on most Hadoop platforms out there. It's just a MapReduce application. Yes?
Do you have multiple configurations of your Hadoop appliance, whether it's more on like an ETL versus an archival? Because in some cases you may vary the nodes or vary, emphasis more on processing versus memory versus storage.
Right, so the question was, are there multiple different configurations for our Teradata appliance because we might want to have different balances of processing and storage based on our needs? And the answer right now is on our appliance, the answer is no. Currently, we only have one configuration that we ship out it's kind of a premium appliance optimized. It is optimized for I/O bound jobs that are traditionally I/O bound jobs. So it is kind of I/O heavy, but that's kind of par for the course with Hadoop type workloads. We also offer supports on a commodity offering, and we will do software-only support for our system. So you could get Hortonworks distribution, put it on your own hardware if you have more specific needs than our appliance, which will meet about 95% of the needs out there. You can take the Hortonworks distribution, put it on your own hardware that matches your wants and needs, and we'll still support that.
But your appliance uses Hortonworks?
Our appliance uses, it's called the Teradata Open distribution for Hadoop. It's based on Hortonworks. We modify it a little bit to match our appliance and optimize it for our appliance, but it's mainly Hortonworks. Yeah, back there.
Can I clear data from a Teradata to Hadoop? Like if half of the data sitting on my Teradata appliance is kind of cold, can I move it to Hadoop and continue running queries on it from the Teradata front end?
The question was, can you take cold data, move it to Hadoop, and then continue running queries on it from the Teradata front end? And the answer is absolutely. What you would need to do is create a view on top of that Hadoop data using our Query Grid connector. Then you could query that view just as if it was a Teradata resident table. Now, behind the scenes, the data would transfer over the network onto your Teradata platform. So it would take a little bit more latency in order to use that active archive type solution in order to query your data. The queries would logically still work. The trade-off is, do you want that is that extra latency to execute these queries worth the cost and performance savings of taking space off of your data warehouse? So you have to balance that, and oftentimes the balance falls in favor of using Hadoop storage if the data is very cold. It's not accessed very often. So if that answered your question. Yes?
So on your commodity offering, are you also running the Teradata software on it or just Hadoop software?
So the question was, on our commodity offering, are we running Teradata software? The answer for that is we run pure Hortonworks on our commodity offerings. The modified version, the Teradata modified version, only runs on our appliance. However, a lot of our ecosystem still functions on the commodity version. Yes?
What's the cost
The, I guess the answer is it depends, and I'm not allowed to talk about pricing. Yeah, the question was, what's the cost ratio? Per terabyte, how we like to analyze it in Teradata, and the question was, what's the cost ratio between a data warehouse and a Hadoop appliance? In Teradata, we like to talk about the cost per query and the cost per terabyte. So our Hadoop appliance, if you try to compare how much it costs to store a terabyte of data on Hadoop, then Hadoop will destroy Teradata in cost comparisons. Hadoop will be much less expensive to store a single terabyte of data than it is on Teradata. Now, if you talk about doing some sort of query or analytic, then we look at kind of the total cost of owning the data and doing business transaction type data. If you saw in that, if I can go back to that bar graph over here. You can see that the total cost of actually owning the two systems is very dependent on the workloads you're putting on the two systems. So again, it's very workload dependent which of the systems will win based on what you're actually using the systems for. If you're doing a lot of business transactions, high concurrency, complex SQL queries, it'll be actually less expensive for total cost of ownership to put that on a Teradata appliance versus if you're doing a big data type storage, then it actually is lower cost to use a Hadoop appliance. Yeah, back there. No, you.
How do you write data into Hadoop as an active archive? How do you do that?
I'm sorry?
How do you write data into Hadoop as an active archive?
Oh, so the question is, how do you write data to Hadoop as an active archive? So you can use one of the two connectors that I discussed here, the Teradata connector for Hadoop, it's kind of like Scoop, but it's also a MapReduce job. You can use that to bulk transfer data between Teradata and Hadoop. You can also use QueryGrid, which is a SQL function that actually is in our latest release now supporting pushing to Hadoop. So you can. And it requires upfront work. You have to decide upfront which data it makes sense to push into Hadoop, and you can use one of these two connectors to, in parallel, move the data to Hadoop, create a view on that Hadoop data, and then you can still access it in your data warehouse without actually having it stored on the data warehouse. Yes. The question was, how much complex queries can we write joining views in Teradata and Hadoop? And the answer is, you can, actually we have a demo we like to use. It's a three-way join between our three different platforms, and you can run it on our data warehouse. And it will move data from Hadoop to Teradata, move data from Aster to Teradata, join all three of them together. You can do some complex things. What I always like to recommend, though, is if you're going to do some sort of long-term or at least even short-term analysis on the data, you actually stage the data in like a temporary table, so to speak, so that you can collect some statistics on it, so your data warehouse knows a little bit about the makeup of the data, so it can make intelligent decisions. The reason, and then we can also do further queries. Let's say you make a mistake with the query. You can very quickly adjust the query, run the query again without having to bring the data back across the pipe, so you save some time. And then when you log out, since it's a temporary table, the table will just drop and your data is gone back on Hadoop. So now the question about complex queries, how much? It's, again, very dependent on the data size, the complexity of the query. If you're running very large data sets, it might make sense to aggregate that down on the Hadoop side by pushing some logic to Hive. You can, if you bring more data into Teradata and stage it in a temporary table, you have a lot more bandwidth to run more intense queries before you drop the data. It's very dependent. That's kind of a complex question to answer here. It's dependent on the data and the workload. Yeah, it happens behind the scenes. Yep. Yeah, over there. I'm sorry, the question was about Aster Data? So the question was, how does the Aster Data platform fit in? And Aster is kind of the third piece of our what we call a unified data architecture. We use Aster for discovery. It's a place where you pull data sources in and you do rapid iterative discovery queries on the data. You try to gain new insights on your data using lots of different what we call SQL MapReduce functions. It's got built-in MapReduce into the database. We can analyze graph data. We can do like machine learning algorithms, text analytics, sentiment analysis, pathing, statistical queries. So we have additional analytic capabilities. We even have R built into it. We have multiple storage formats like a file store, a relational data warehouse store. And we have different processing engines like SQL, SQL MapReduce Graph, and all of these kind of merge together to allow us to discover things about our data very, very quickly. So we use Hadoop for big data and massive data storage and processing. We use Teradata for business operational queries and processing. And we use Aster for discovery data queries and processing, iterative discovery. Yeah. Yeah, over there. Can you repeat that? So the question was, how do we restrict security using the secure access architecture? So what we actually do here is, and again, imagine that these are swapped, Teradata's on the left, Hadoop's on the right. What we actually do is we can put like a firewall in between the two platforms so that end users can't access Hadoop directly. That way we can keep it with simple authentication. So it doesn't break connectivity with other things, but we still prevent end users from impersonating anyone they want. Then we can have Teradata users log into Teradata, and they can only access Hadoop data through views because we've disabled that function. So then we grant views to Hadoop data to specific users, and those users are only allowed to access the data they've been authorized to access on the Teradata side. They can't go around that because of the firewall. They can't go around that and just impersonate anyone they want and read data on Hadoop. So this is how we can securely implement an unsecured Hadoop cluster using a data warehouse as an access layer here. Yes? The question was, can we, using the ETL architecture, meet the same service levels that we can in Teradata? And the answer, of course, is that depends. This is why I kind of had that disclaimer here. There are many cases where it makes sense, and there are many cases it doesn't make sense to put ETL on the Hadoop box. And some of it may depend on the service level. It may require a little bit of experimentation. A lot of times with Hadoop, you can scale it to a point. You can certainly scale it to a point where it definitely will go through in the amount of time you have allotted for the queries to run. And there are times, again, where it might not. You might want to keep it on your data warehouse. Again, it depends on the trade-offs. There's a trade-off here. It doesn't necessarily make sense just to stick all of your ETL on Hadoop. And it's very dependent on the data and the workload. Yes?
In this model here, if you have multiple users that are changing the ETL and potentially adding extra columns from the data in Hadoop and loading into Teradata, is it possible to do that easily without reloading the entire data, rerunning the entire ETL?
So adding in extra columns was the question. So say maybe a new data set has an additional column versus the old data set. How that would work is you definitely could, and that's one of the advantages of putting the data on Hadoop. You have that flexibility that Hadoop comes with. So you can load the data in a Hive if you're using Hive, and then change the schema to indicate that extra column. The extra column would be null on the other ones, filled in on the new data set. And your Teradata query, or your query that pushes it to Teradata, could leave out that extra column in order to keep it the same on Teradata. So it actually the only change that would be required in this case would be a Hive schema change, and then you could keep the same workflows that you had before. In Teradata, running out of time. But this will be the last question then. In Teradata, could you add the extra column without redoing the entire ETL? The answer is you can alter the table in Teradata, and an alter table will actually add an additional column, null out the column in the existing table, and then you could keep inserting data. Yes. So thank you very much, everyone. That's all I have.